right, this video is going to show you how to graph systems of inequalities and what the picture and answer should look like. I know that I am not here in front of you to show you what this is, but you already know how to graph the single line, so putting 2 or 3 in the same graph shouldn't be that difficult. If you wish to use colored pencils for these, it does work a little bit easier. You'll notice I use 2 or 3 different colors because you can see the different lines. So if you wish to go ahead and get 2 or 3 colored pencils from my side containers on the bookshelf, I am okay with that. Right? I am going to work out a couple of these in person or in video for you, and then the rest I want you to try on your own. So I am going to skip around a little bit so that you can see a whole different variety of questions. So we will go ahead and take number 2, right, to work out together. Okay. And you remember that both inequalities have got to be in slope-intercept form, so in this case number 2 is. And the way these graphs are set up, as long as you number them, which inequality system you're using, then it'll be whichever graph goes with which number. So I'm going to put number 2 over here on the right. First thing I want to do is graph y is greater than negative 2x plus 5. So I'm going to start at positive 5 on the y-axis, and my slope is down to right 1, down to right 1. And remember, before you connect the dots, you always ask yourself solid or dashed. It is a dashed line because it does not have a part of the equal bar. So I make my line dashed with my straight edge. Okay, and then remember that you always have to shade. So because it's y is greater than negative 2x plus 5, greater than would be the top side of the graph. All right, so there's that line. Now we're going to graph the second one in the same coordinate plane so that you can see what's happening. All right, so we're going to start this one at positive 1 on the y-axis, and the slope is positive 1, so that means up 1, right 1. And we want to ask ourselves solid or dash. This one is solid because it has a piece of the equal bar. So you make a solid line running through the graph. Okay, and then because it's less than or equal to, we're going to shade underneath it. Right. Now, the answer to a system of inequalities is not one ordered pair. It is a section of the picture where the color overlaps or where the shading overlaps, right? And it's got boundary lines. So if you take from here and run all the way down to the dashed line and then run along that dashed line over here, this whole section over here that I'm darkening in is the answer to the system. So it is not one little numbered set, it is in the picture. Your picture is your answer. So you do need to darken in for me where the two overlap so that I can know that that's where you're telling me the answer is. All right, so make sure that you're doing that each time. All right, so let's go and try another one together. All right, let's go ahead and jump down to number 4. All right. So in number 4, you'll notice that both of them are not in intercept form. All right, so we need to take and go ahead and do that. So for the first one, I need to subtract x from both sides. That leaves me y is less than or equal to negative x plus 4. Okay, and then for the bottom one, I'm going to have to minus 2x from both sides. That gives me negative y is less than or equal to negative 2x plus 4. I'm going to divide by negative 1, and remember, when you divide or multiply by a negative, you also have to flip the symbol around. So this one is going to be y is greater or equal to 2x minus 4. And now I'm ready to graph both of them on the grid. All right, so I'm going to start with the first one. It starts at positive 4 on the y-axis, and the slope is negative 1, so down 1, right 1. And then you ask yourself solid or dashed, and this one is solid. So you take and draw your solid line. And because it's less than or equal to, it is shaded underneath the line, which is all this big region down here. Okay, then we're going to graph the second one. So we're going to start at negative 4 on the y-axis. And it has a slope of positive 2, so that's up 2, right 1, up 2, right 1. And it is also solid. So you draw another solid line. And this time we want to shade greater than, so that would be on the top side. So now you can see where your two shadings overlap, or if you're using colors, it's very easy to see where the two colors overlap. And now you want to darken in that region. So you want to use the boundary lines from the one going downhill and the boundary line from the one going uphill. So this whole left side over here, all of this is your answer region. Okay, so that's what the picture would look like in terms of an answer. All right, so I'm going to let you play around with the other 4 on this front side and see if you can come up with a picture that works. All right, so just be consistent and look for the places that your shading overlaps. Now, if you'll go ahead and flip to the back, we are going to not do number 9, right? Because number 9 has, actually, hold on a second. We will do number 9. We are not doing number 8 because number 8's region is so small, it's so hard to see on the actual graph. All right, so number 7's graph is right here, and then number 9's graph is down here. For number 8, we don't need to use it, so you're not even using the other one. All right, let's go ahead and do number 9 together, and then I'll let you practice with number 7 on your own, because then you'll be able to see whether you understand what you're doing. All of them are ready to go except for the last one, so we need to take the last inequality and we need to divide by 4 on all of them, and that gives us y is greater or equal to negative 15 over 4x minus 8. Right? So yes, the slope is quite steep, but if you look at your grid, your squares are a lot smaller, and it's because of having to count 15 over 4. All right, so let's go ahead and start with the top one, 2x minus 8. So this is where you might want 3 colors if you're using different colors. So I'm going to start at negative 8, which is right here, and I'm going to go up to right 1, and then I'm going to take and make a solid line through that. Right? And because it's greater than or equal to, it's the top side that's shaded. So a big area up there. All right, then I'm going to take the second one and go to positive 6. And then the slope is negative 1/4. So that means down 1 and right 4, down 1 and right 4. And that one's also solid. Okay, and it is less than or equal to. So it goes down here too. So now we've got this region on the left that's got both colors in it right now. So we're going to put in the third one, which starts at negative 8, which is right here. And then from negative 8, we're going to go, we can't go down 15 and right 4, so we're going to have to go up 15 and left 4, and you will only be able to get 2 dots on this graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 1, 2, 3, 4. So it's right here in that second quadrant. And it is also going to be a solid line. Okay, and it is greater than or equal to, so that's shaded this way. So now the tricky part is looking to see where do all 3 lines, the shadings, overlap. And if you're using color, it's a little easier to see. Mine might look a little messy just because of my markers, right? But there is a boundary line with the green line that comes down to a point, the boundary side with the red line that comes down to a point, and then the blue line is a boundary edge, right? And so everything in this triangle right here is your answer. Okay, and typically if you have 3 inequalities in a picture, you do get a triangle for an answer. Every now and then you don't, but for most of them you do. So try and look for those triangles if you end up with 3 systems. All right, so go ahead and try number 7 and see if you come out. You should come out with a triangle. It's not as large as the one we just did, but it should be another triangle. All right, and then I want you to take and use the ability to graph them to turn around and write an inequality once the graph is already made, just like we practiced doing before with the single lines.